Today we are going to start mean value theorem and Rolle's theorem and Lagrange's mean value theorem. For Rolle's theorem, there are three conditions. First, functions function should be continuous on closed interval AB. If it is continuous, then it should be differentiable in open interval AB. If these two conditions are okay, then the third condition is that f of A should be equal to f of B. The three conditions are continuity in closed interval, differentiability in open interval, and then at the last initial point and the last point, f of A should be equal to f of B. If these three conditions are satisfied, then Rolle's theorem says there is a point C which is an element of AB such that f dash C is equal to 0. What does this mean f dash C is equal to 0? The derivative is always the slope of the tangent. So if the slope of the tangent is 0, isn't the tangent is parallel to x-axis? So if a function is continuous closed interval, differentiable in open interval, and f of A is equal to f of B, f of A is equal to f of B, then there is at least one point in C, there is some C in AB such that f of C is equal to 0. Means at some point the tangent, slope of the tangent is 0, means the tangent is parallel to the x-axis. It says the Rolle's theorem. Now in mean value theorem, what is the difference? In mean value theorem, first two conditions are same, that a function is continuous in closed interval AB. It is differentiable in open interval AB. Then it says there exists a C, an element of AB, such that f dash C is equal to f of B minus f of A upon B minus A. So if you have a curve, A, its value f of A in function. B, its value of the function at B. So isn't it the slope? Here, sorry. So isn't it the slope of this secant? Y2 minus Y1 upon X2 minus X1. We have done slope of line between 2 points right now. So what I am getting, that if these two conditions are okay, continuity in closed interval AB, differentiability in open interval AB, then there exists a C, an element of open interval AB, means it can't be A or it can't be B. It means this. Then f dash C means slope of the tangent, slope of tangent is equal to slope of secant. Why I am calling it a secant? I am not taking it as a chord. Any line cutting the 2 points. So this is your Lagrange's mean value theorem. Okay. So now we will check the applicability of the Rolle's theorem and Lagrange's theorem in the questions. Now before that, before you start the question, remember every polynomial function is continuous. Every polynomial function is continuous. Every logarithmic function is continuous. Every exponential function is continuous. Every trigonometric function is continuous except this one. Tan x is not continuous at plus minus pi by 2, 3 pi by 2, because there is a function is not defined. Otherwise, uh, all of the sine cosine means everywhere continuous as well as differentiable. See here, the polynomial function is everywhere continuous and differentiable. Just check the difference between a polynomial and the algebraic expression. It's a polynomial function. The exponential function, sine function, cosine function, and everywhere differentiable and continuous. Logarithmic function is continuous in and differentiable in its domain. Domain is x is greater than 1. And 10x is not continuous, that is given. Then mode of x is not differentiable. And remember, for differentiability, the exception is this. If the curve is having point anywhere, it's not differentiable over here. For differentiability, the curve should be smooth, not a corner point. Having a corner point doesn't give you tangent. Okay, so if it is pointed, it doesn't give you differential. So mode doesn't have, as mode is this, mode function is this. Now f dash x tends to minus infinity and plus infinity. As x tends to k, then k f of x is not differentiable at k. I mean, say infinity cases are not discussed. Next, let us go to the exercise. First question says, verify Rolle's theorem for this. As you check, f of x is a polynomial, x square plus 2x minus 8. X is an element of minus 4 and 2. It's a closed interval. So we have to verify Rolle's theorem. So first case, being polynomial, it's a polynomial function, not algebraic expression. Being polynomial, f of x is continuous in closed interval AB. So minus 4, 2. Second, being polynomial, it's differentiable. F of x is differentiable in minus 4, 2. Therefore, f dash x is 2x plus 2, right? Third case, f of minus 4, that is equal to minus 4 square plus 2 into minus 4 minus 8. So this is 16 minus 8 minus 8. So this is 0. Okay. And then f of 2. This is 4 plus 2 into 2 minus 8. So 4 plus 4, 8 minus 8, 0. So can we say f of minus 4 is equal to f of 2? So all the three conditions are clearly valid over here for this function. Therefore, by Rolle's theorem, what can we see? F dash C is equal to 0. C is an element of minus 4 and 2. There exists C. This is for there exists. This symbol is for there exists. This is there exists an element C, an element of minus 4 to open interval such that f dash C is equal to 0. So put the value over here. 2C plus 2, that is equal to 0. For C is minus 1. So C is minus 1. You can check minus 1 is an element of minus 4. So this is the first question. Second question, if you check greatest integer. What is greatest integer function? This is by definition, it is if x lies between 0 to 1, then it is 0. X 1 to 2, this is 1. X 0 to minus 1, this is minus 1. Means this is this type of function. So this function is not continuous at every integral value. So what will you write? As mod of x, sorry, latest integer function x is discontinuous at every integral value. Therefore, first condition is not applicable. So we are not, Rolle's theorem is not applicable. Same you can say for this also. Because these functions are not in this continuous as well as differentiable. For differentiability, you have to check just left-hand derivative and right-hand derivative. We can show they are not differentiable. I'll just put a video for that also when I'll show you differentiability. Then part 3. Part 3 says f of x is x square minus 1. Interval is 1 to 2. So it's also a polynomial. So first condition, being polynomial, f of x is being polynomial. F of x is continuous in closed interval 1 to being polynomial. Second condition, being polynomial, f of x is differentiable in open interval 1 to. Then third condition, f of 1 is 1 minus 1 is 0 and f of 2 is 4 minus 1 3. So as f of 1 is not equal to f of 2, therefore Rolle's theorem is not applicable over here. Clear? The Rolle's theorem is not applicable over here. Next question. Third question. F is from -5 to 5 and R is differentiable function. This is given to us that R is differentiable. F dash x doesn't vanish anywhere. Means f dash x is not equal to 0. Then prove that f of -5 is not equal to f of 5. So we take, if f of x is R is a differentiable function, then it is continuous also. Every continuous function is not differentiable, but every differentiable function is continuous. Remember that. Every differentiable function is continuous, but every continuous function need not to be differentiable. It can be or it might not be. So let us take f of -5 is equal to 5. All the three conditions of Rolle's theorems are satisfied. Then sorry, it is differentiable, so we are taking it as continuous function. And if we take f dash c is equal to 0, then it is wrong now, because it says f dash x doesn't vanish anywhere. So if we say Rolle's theorem is applicable over here, then that is a contradiction, because it says f dash x is not becoming 0, but by this it will give us, if we take f of 5 is equal to f of -5, then f of dash c should be 0. But it is not equal to 0. This is given to us. Therefore, this is not true. They can't be equal. Clear? For the Rolle's theorem, first it is given differentiable. Every differentiable function is continuous. So f of x is continuous, f of x is differentiable. So we have taken f of 5 is equal to f of -5. So what is that? Then there exists a point C such that f dash c is equal to 0. But f dash c is never 0. It is given over there. So this supposition is wrong for us. So f of 5 can't be equal to f of -5. Clear? Next question. Mean value theorem, fourth question. It's a polynomial. So continuous in the open interval 1 and 4. right? Continuous. Then polynomial function, differentiable. Open interval 1 and 4. Then what does the mean value say? There exists a C an element of AB such that f dash C is equal to f of B minus f of A upon B minus A. So find out f of B. F of B is 4. F of 4. So that is equal to 16 minus 4 into 4 minus 3. So 16 minus 16 cancel. So this is minus 3. What is f of 1? 1 minus 4 minus 3. So this is minus 7 plus 1 is minus 6. Then what is f dash t? If we differentiate that, it will f dash x is 2x minus 4. So from here, what can we say? If we apply this, 2c minus 4, that is equal to minus 3 minus of minus 6 upon b minus a. B minus a means 4 minus 1. Clear? F of b minus f of a upon b minus a. So this is minus 3 plus 6 upon 3. So this is 3 upon 3, 1. So 2c is equal to 5. So c is equal to 5. Clear? Same for this question we can say. Question number 5. When it's written mean value theorem, it's always Lagrange's mean value theorem. F of x being polynomial is continuous in the closed interval 1, 3. Continuous in closed interval 1, 3. Being polynomial, f of x is differentiable in open interval 1, 3. Then there exists a C such that f dash C, because mean value theorem is first part. F dash C is equal to f of B minus f of A upon B minus A. So f of B is 3. 3 into 3 cube. 3 cube. 3 cube minus 5 into 3 square minus 3 into 3. So this is 27 minus 9 5 is 45 minus 9. So this is 27 minus 54. So minus 27. Next, what is f of 1? 1 minus 5 minus 3 minus 8 plus 1 minus 7. So f dash c. What is f dash x? That is 3x square minus 10x minus 3. So f dash c will be minus 27 minus minus 7 upon 3 minus 1, that is equal to 3c square minus 10c minus 3. So this is minus 27 plus 7 by 2. That is equal to 3c square minus 10c minus 3. So this is minus 20 by 2. That is equal to 3c square minus 10c minus 3. So minus 10. To solve this, this will give you 3c square minus 10c minus 3 plus 10. That is equal to 0. So 3c square minus 10c plus 7. That is equal to 0. So 7 and 3, 21. So 21 and sum should be 7. So isn't it 3c square minus 3c minus 7c plus 7. So 3c common, c minus 1 minus 7 common, c minus 1. So this is giving you 3c minus 7 and C minus 1 is equal to 0. C is equal to 1 and 7 by 3. Now check. Uh, Interval is 1, 3. So C should be an element of open interval AB. So C is an element of 1, 3. So it can't be equal to 1. C can't be equal to 1. Therefore, C is equal to 7 by 3. This is your mean value theorem, right? Then what is the second part? Find all C for 1, 3 for which f dash C is equal to 0. We also need to find that also. Hence, this is verified. Now, if we say f dash C is equal to 0, so 3C square minus 10C minus 3 is equal to 0. So, 9 and this